Question 2. What is a pattern? What is an anti-pattern? Is dependency injection a pattern? First, let's have a look at the definition. A software design pattern is a reusable solution to often commonly occurring problem in software design. It is a high-level description on how to solve the problem that can be used in many different situations. Design patterns often represent best practices that developers can use to solve common problems. Now, let's go into the code and let's have a look what does it actually mean. So, open the examples provided within this course and go to the question 02. In question 02, I'm showing how we can apply the builder pattern to optimize part of the code for it to look better and also to write less code to achieve the same result. So over here I have a runner class, and this runner class interacts with the class called text renderer. This class text renderer gives me ability to render the text on my screen with usage of different options. So now let's start this class. So as you can see over here on my screen, I can see that the first default rendering produced the default weight, default color, and also default style. Now the second line produced the red color, which is different from the default color, and the third line produced the bold rendering, which is different from the first line. As you can see in the code, even if I am using all default renderers, like on the first line, I have to provide all of them. And even if I want to change the rendering from the default to the red, and I want to change color and just color, I need to provide all of the renderers as well. The same applies if I want to change the font weight rendered from the default to the bold. So the issue is that every time when I want to use the different text renderer, even though only one property is being changed, I need to provide all of the properties, all of the renderers to this class. So under the hood, text renderer in this version is a class that takes all of the dependencies from the external. And this is great, but still some coded application exists over here. Now go ahead to the after package, and after package shows how to do the same, but how to avoid all of those duplications. So go to the runner, now run the runner, and let's wait for the results. As you can see, the results are the same, however the code is different. We are avoiding all of those duplicates, and if I want to create a default renderer, then I do not need to provide any renderers. Basically, I'm using the text renderer builder that provides all of the default values to the text renderer. If I want to change only the font color renderer, then I am able to do so without providing other default values. If I want to change only the bold rendering, then I'm doing the same without providing other renderers. The way that is implemented under the hood is with usage of the builder pattern. Now the builder pattern assumes that we have an object that is being constructed. However, this object has private constructor. This private constructor cannot be called from the external world, but to create this object, we need to use the text renderer builder class. This builder class creates all of the fields that has to be injected into the text renderer with all of those default values. If I want to change the default value, then I'm using the methods that allows me to set the field values in this text renderer builder, and after that I'm invoking the build command, which will call this constructor. The advantage of using this pattern is that I am able to easily construct the default objects without adding any additional renderers or any additional dependencies. And if I want to customize something, I can just inject the customized renderer customized field. So basically, this is how design patterns help us to create better software that is written with the best practices. And a lot of design patterns that are commonly used can be found in Gang of 4 design patterns. Those are some of the design patterns that are part of Gang of 4 design patterns, like factory method, builder, template method, strategy, observer, visitor, facade, and composite. And also, yes, dependency injection is a pattern, and it solves problem of flexible dependencies creation. Now, if we know already what is a pattern, now what is an anti-pattern? The anti-pattern is basically a solution to often occurring problem that was identified. However, unfortunately, this solution is ineffective and it's counterproductive. So there are some examples of anti-patterns in object-oriented programming that I'm providing here below. The first one is called the God object. The God object is basically where we create a class that is huge. It has a lot of responsibilities. It has a lot of sometimes constructors. It has a lot of fields, etc. And it's actually hard to tell what is the life cycle of this class, what are responsibilities of this class, what is the main goal of this class. And it's really hard to change, hard to test. It's hard to reason about it, and whenever you actually change it, something gets broken. So basically, God objects are really bad because also they are violating the main principles of the object-oriented programming, which is about creating a software in small objects, and each object should follow its unique and small responsibility. The second anti-pattern that I have added over here is a sequential coupling. It's when you have one object that is calling other object and you need to call those methods in a specific order. If you will call the methods in the different order, then either you will have a null pointer exception or you will have unexpected behavior. The next one is circular dependency. Is, for example, when you have a module A that is dependent on the module B that is dependent on the module C, and then module C is dependent on the module A again. This is when you have a circular dependency, and the issue with this is that there is no way to actually compile the code because there is no way to solve the dependencies in a way that you can compile the first module and then the other modules can be supplied by the dependencies. The last anti-pattern that I'm providing over here is called the constant interface. Is when you are defining the constants on the interface level in Java. And this is basically wrong because the constants are usually used as the internal parts of your implementation. This is implementation detail. And when you are having them on the interface level, you are exposing them through the API. So the important thing to remember from this lesson is that the software design pattern is a solution to commonly occurring problem in a software design. It's not ready implementation. It's more like high-level description on how to solve the problem. In the example, I have provided how builder pattern can be used to optimize the code, how to create a better code. And also it is important to remember that the dependency injection is a design pattern. Now the anti-pattern, on the other hand, is something quite opposite. It's when we have the solution to the problem, but this solution to the problem is ineffective or counterproductive. If you enjoyed this video and would like to retrieve explanation to other Spring exam topics, you can get a full Spring Professional Certification exam tutorial course by following the link in the description.